And so now for part 2 of lab number 1. And as I mentioned, there are just a couple of things that we needed to cover, and then you'll be good to go to get into the lab. First, I wanted to talk a little bit about safety concerns. We have, in the U.S., material safety data sheets, and there is an example in Appendix A, on page 84. And so what those are safety, they include safety information about chemicals. And so in this lab we are going to start a little bit about working with real chemicals. And so just a heads up, your instructor may have you write out the safety information for all the chemicals in lab, or all the relevant chemicals in lab. So looking at their MSDSs would be a good source to go to. And so Appendix A is an example. You can go to Sigma Aldrich or Fisher Scientific, and I will include the links to these in your pre-lab quiz so that you can have them as sort of a resource for finding out safety information about what you'll be dealing with in lab. And a couple of safety things to think about, or just maybe definitions. The flash point, if you haven't talked about it in class, the flash point is the lowest temperature at which a substance might ignite. There has to be a source of ignition, but still, if this is a really low temperature, you might want to think about just working in the hood with that. Chronic versus acute. Chronic means that you're exposed to a substance over a long period of time, and if the MSDS says that it can chronic exposure can cause damage, then that means that you're exposed to it over a long period of time and it's not good. The MSDS would give more specific information. Acute means that even a one-time exposure can be very harmful, and so if something causes damage upon acute exposure, that means even just with one shot. When you look up MSDSs, you'll see chemical abstract service numbers, or CAS numbers. Those are just like the barcodes for chemicals. So all the chemicals that get sold in this country will have a CAS number. Mutagen can change DNA or cause cancer. I typically have my students sign a safety contract, and I don't want to force you to give information that you're not comfortable with, but I will ask, well, are there any special circumstances that you would be comfortable with sharing with your instructor? So for example, I am super pregnant right now, and I should not be around any mutagens. So that would be something, if you're comfortable with, that it would help the instructor to know safety-wise. Of course, also at DMAC, we always try to reassure, or we always try to ensure that we only deal with very non-toxic chemicals, but you still, if you're doing an inquiry project where you're making up your own experiment, it's still kind of helpful. Another thing besides pregnancy would be color blindness, because a lot of our qualitative observations will rely on color. Or another thing that you might want to give your instructor a heads up about is if you wear contacts, because some of the chemicals that we use can fuse contacts to your eyes if you're not wearing your goggles. Of course, you will always be wearing your goggles, so that should, of course you're wearing your goggles. And last but not least, so let me write this up where you guys can see it. Another thing that you will see in MSDS is if a substance is a suspected carcinogen, or if it has been identified as a carcinogen. And so that means that it can cause cancer upon exposure. And at DMAC, we've been really good at not having you guys play with carcinogens. And so we do try to eliminate risk as much as possible, but it's also not a bad idea to know what kind of risks are out there generally, and to be empowered enough to be able to find out the risks yourselves. So last but not least, you will be doing a little bit of lab work, and it should be in the hood because it is with volatile substances, and you'll be looking at their solubility. Now in Gen Chem, we kind of considered solubility to be, oh, well, always assumed to be in water. And why does something always have to dissolve in water? Maybe we're dissolving it in another substance, like hexane. And if you think back to Gen Chem, like dissolves like. If we have a really polar substance, yes, it'll dissolve in water because water is very polar. If you have a very non-polar substance that you're trying to dissolve, well, if you put it in water, it will not dissolve. It will be insoluble. And so what you'll be looking at is, with solubility, is there an interface? So you'll be taking you'll take two liquids and you'll put them in an evaporating dish or in a container that will help to hold the liquids in, and see if there is an interface in between the two liquids that indicates that they're not soluble with each other. And then also cloudiness. If you see kind of a haze, that indicates that they're not soluble in one another. Another thing you'll be looking at is how long does it take for for the same amount of different substances to evaporate. So you'll be looking at, we could call them rates of evaporation. And so kind of a key thing to keep in mind is your timing, how long it takes for something to evaporate. And so what you can do is you can take your container, like whatever container that you're using that will hold in liquids. And a couple of things to keep in mind, or one thing to keep in mind, is that the smaller amount of substance that you start with, the less amount of time you have to wait around waiting for it to evaporate. And so if you have 10 milliliters of something, it's going to take longer to evaporate than if you have just a couple of drops. But then you also want to balance that with, well, how accurate is it if I only start with 2 drops of hexane? Am I really going to know its behavior? Am I really going to track evaporation very accurately? What are the sources of human error with my own eyes? And so those are a couple of things to kind of balance in terms of thinking about how to set up your evaporation observation. So with that, this is the lab that's written in the manual, but we should have more time to do our experiments. We're going to take a little leisure time because of these videos, and so we'll also be able to do a little bit of inquiry. So what I want you guys to do after this is to plan out and investigate a new physical property in lab. And so if you are in my class, what you'll do is you'll make a Google Doc and you'll share it with me. And the first thing you'll do is, for all your inquiries, so Google Doc, share, and then my Gmail is my name. And I will also write this out along with the links to Sigma Aldrich and to Flynn. So Google Doc, share it with me. The first thing I want to include is a title. So instead of looking at the solubility of, say, hexane in water, maybe you'll want to look at the solubility of cyclohexane and hexane. Or maybe you'll want to look at the solubility of cyclohexane and water. So you'll give it an apt title, a relevant title. Then you'll want to write a purpose. So let's say for our inquiry project, let's say instead of looking at solubility, we want to see when something will freeze. That's another physical property that we could look at. So our purpose would be, we could say, well, to investigate the freezing when a mixture of hexane and water will freeze. And then I want observations. I want a procedure, so what did you do? And if you have a device, like if you have your camera on your cell phone, then also include, if you have a picture of what you did, like a setup, like let's say you set up a new way, figure out a new way to set up lab, that would be great. Include a picture, observations, and then last but not least, a conclusion. And your conclusion should be basically a rationale. This is exactly what I saw. I saw an interface. I saw something freeze. I saw it start to get sort of crystally and frozen, and at 5 degrees Celsius, and then at 2 degrees Celsius, it was really frozen. And then a conclusion should be explaining, based on what I did, what I observed, why. It should be the what and why. So with that, I'm going to let you guys get started. Go ask me questions, go work and collaborate with your classmates, and then take your pre-lab quiz, and then you are ready to go for lab number 1.